All right. Well, we are going to be talking about stoichiometry and more specifically how to calculate the mole-mole and the mass-mass conversions. So I'm going to run through this with you guys. So we're going to start with section 8.3. This should be a review for you, but it's good to go through an example and have you try one before we jump into the sort of expanding on this. So section 8.3, which we've talked about, is called mole-to-mole conversions. You guys have already done this, but like I said, it's good to review. So step one, we have to have a balanced equation to do any of this. Remember, this is our recipe. So our balanced equation right here, and our coefficients are going to be really important. So we have 2 moles, 1 mole of chlorine, and 2 moles of sodium chloride. And again, this is a mole ratio, okay? So the next part is just to read through the question and pull out what's given and what to find. So how many moles of NaCl? So that's what I want to find. So I'm going to put question mark, moles of NaCl, sodium chloride. So that's what I want to get to. So how many moles of sodium chloride result from the complete reaction of 3.4 moles of chlorine gas? So this is where I want to start. This is what's given, 3.4 moles of Cl2. So I have my balanced equation. I know where it is given, and I know what I want to find. So at that point, I'm just going to set up my dimensional analysis. So 3.4 moles of chlorine. Okay, now I don't want to put numbers in yet. I just want to deal with the units. So I want to put moles of chlorine on the bottom because I know I want to cancel that out. I want to get to moles of NaCl, so I'm going to put that on the top. And now I have some sort of mole ratio that I need to figure out. Now, again, this comes off of the balanced equation or the recipe. The recipe tells me that for every 1 mole of chlorine gas, I'm going to make 2 moles of sodium chloride. So those coefficients, the 1 and the 2, come right off the balanced equation. And then I'm going to cancel my units. So now it's 3.4 times 2, so this one should be pretty easy. Don't need a calculator for this one. 6.8 moles of NaCl. Okay, and again, this starting number has 2 significant figures, so my answer has to have 2, which it does. And it has a unit, moles, and it has whatever that substance is, NaCl. So that's sort of a review of what we have already done, but using that balanced equation. Okay, this would be a good point for you guys to pause this and see if you can try one. Same type of problem. So in 1781, Henry Cavendish found that water was the only product that results from the combustion of hydrogen with oxygen. How many moles of hydrogen, what I want to get to, or what I want to find, are required to react with exactly 4.3 moles of oxygen? So my given is 4.13 moles of oxygen, and I want to find moles of hydrogen gas, so H2. Okay, so step 1, balanced equation, check. Step 2, I need to figure out what's given and what I want to find, which is a check. And then the last step is just setting this up. And again, you can pause this and you can try this if you'd like at any point during the process. But I'm going to go ahead and go through this. So 4.13 moles of O2. Okay, again, I'm going to put my units on the bottom first. I'll think about the numbers later. So moles of O2. I know I want to cancel that out, so that's going to go on the bottom. I want to get to moles of H2, so I'm going to put that on the top. My mole ratio comes right off the balanced equation. 1 mole, according to the balanced equation, 1 mole of O2, I'm going to need 2 moles of H2. So there's a 2 moles there, 1 mole there. I'm going to cancel my units. And then I'm going to do 4.13 times 2. Again, probably don't need a calculator for this. 8.26 moles of H2. And I am done. 3 significant figures to start with, so I need 3 significant figures in my answer. Okay, so those are called mole-mole conversions because we start with moles and we end with moles. Okay, now mass, just like it sounds. We're going to start with mass and we're going to finish with mass. Now, mass is a much more practical unit to work with because in the lab, we can't like weigh out stuff in moles. That just doesn't work. So we need to convert this to grams because that's something that is actually useful. So a chemical equation, our recipe, always gives us the mole ratio. So it's the mole of reactants and the moles of products, which is kind of helpful, but what we're more interested in is the mass or the grams of the reactants and the grams of products, because I want to know how many grams of this stuff do I need to start with? How many grams am I going to make? That's much more practical for us because we have scales that weigh in grams. We don't have any scales that weigh in moles. So, because our moles, our recipe is in moles, we're going to have to convert to moles first. So we're going to take the mass of our starting point and we are going to convert it to the number of moles. The reason why we're going to convert to moles is because our recipe, our balanced equation, is in moles. So we need to convert to that first, and then once we have an answer, we're going to convert it back to grams. Now notice here it says molar mass, molar mass. So this is where the periodic table is going to come in super handy because we're going to need that on the first step to convert grams to moles. Then we're going to need our balanced equation in that second step. And then we're going to need the periodic table in the third step. Okay, so it's very similar to what we did before. There's just one extra step at the beginning and one extra step at the end. But it's not too bad because we're going to just use the periodic table. So we're still going to start with a balanced equation. So on this problem, here's our balanced equation, check. We're also going to have a step 2, which says figure out what's given and what I want to find. So the problem says how many grams of water? That's what I want to find. Question mark, grams of water. Okay, how many grams of water are produced from the reaction of 84.5 grams of octane, C8H18, with an excess of oxygen gas? So that is my given, 84.5 grams of C8H18. So again, this is octane. This is basically the main component in gasoline. So when you put gas in your car, this is what happens. Your car goes through a combustion reaction and it produces CO2 and H2O and a lot of energy, which is what makes it actually go. All right, so we're going to start with the given. So 84.5 grams of C8H18. Okay, now here's the new part. We need to convert to moles because our recipe is in moles. So I'm going to put grams of C8H18, just like we did before. We're just going to start with the units. I want to convert that to moles. So I'm going to convert it to moles of C8H18. And I know that 1 mole of anything on the periodic table equals the molar mass. So if I add up 8 carbons and 18 hydrogens off the periodic table, I'm going to get a certain mass, and it turns out that that comes out to be 114.26. Okay, again, 8 carbons and 12 hydrogens, if I just take the masses off the periodic table and add them up. So now I'm going to cancel out my grams of C8H18, and now I'm at moles of C8H18. I can do the exact same thing on the next step. I can just put moles of C8H18 on the bottom because I know I want to cancel that out. Now here's where we're going to use the balanced equation. I want to use this mole ratio. And again, I want to get to water. So I'm going to put moles of water on the top. Now I'm going to go to my balanced equation. So C8H18, it says 2, coefficient of 2, so that means 2 moles of C8H18 will make 18 moles of water, according to my balanced equation. Okay, now I cancel out moles of C8H18. I'm at moles of water. Now the last step, I want to go back to grams. So I'm going to put moles of water on the bottom, and I'm going to put grams of water on the top. And I know that 1 mole of anything equals the mass off the periodic table. Okay, and again, if I add up 2 hydrogens and 1 oxygen, I will get 18.02 right off the periodic table. Now I just need to multiply everything on top, divide by everything on the bottom, and it comes out to be 119.9 and a bunch of other numbers after it, I believe. And we want 3 significant figures because that first number has 3. So this one, you actually have to round it to 120 and then put a decimal point after it. That's the only way to get 3 significant figures out of that number. And then grams of water. Okay, so just like what we did on the first page, we're just adding a step at the beginning, converting grams to moles using the periodic table. And then we're using an extra step at the end, which is converting it back to grams using the periodic table. And that's it. So question number 2, if you want to pause this and try practice problem number 2, you can try that going from start to finish, which I recommend doing. I'm going to keep going and just start working on this. So step 1, balanced equation, check. Step 2, do I know what's given and what I want to get to? So how many grams of aluminum chloride? That is what I want to find. Grams of aluminum chloride. And 18 grams of hydrochloric acid. So that is where I am starting. 18 grams of HCl. Okay, so I have my balanced equation. I know what I want to find. I know what's given. So now I'm going to take what's given and I'm going to convert it to moles. Because again, my recipe or my balanced equation is in moles. So 1 mole of anything off the periodic table equals the molar mass. So if I add up 1 hydrogen and 1 chlorine, I should get 36.46. Okay, I'm going to cancel out the units. Moles of HCl is going to go on the bottom. So this next step is right off the balanced equation. So moles of HCl, and I want to get to aluminum chloride, so I'm going to go moles of aluminum chloride. Now I'm going to go to the balanced equation. 6 moles of HCl is going to give me 2 moles of AlCl3. Cancel the units. Now I'm at moles of AlCl3. I want to put moles of AlCl3 on the bottom, and I want to convert that back to grams of AlCl3. So 1 mole of anything equals the mass off the periodic table. This one, if I add up aluminum and 3 chlorines, I get 133.33. Okay, I'm going to cancel that and cancel that. Now I'm going to multiply everything on top, divide by everything on the bottom, and I come up with, I think this one comes out to be 21.9 and a bunch of other numbers. So because we're starting with 2 significant figures, I need to round this to 2, so I call it 22 grams of AlCl3.